Professor James Renwick is fascinated by the general circulation of the atmosphere, how it transports energy and momentum, and what it does to achieve all this. James is also involved with climate prediction work. From next season to the end of the century and beyond, he has been involved with the IPCC and processes since the early 2000s, speaks regularly to the media on climate change issues, and in 2018 won the Prime Minister's Science Communication Prize. He is a professor of physical geography at Victoria University, and we welcome him to the show. Hello, James.
Hello, Pat, and thanks for inviting me on.
Look, we're very excited to have you on. We love the conversation. We speak to many people who have written for the conversation, and your article in this current day, not day and age, but this day, about all the Auckland floods are a sign of things to come. The city needs stormwater systems fit for climate change is incredibly appropriate, and we want to talk to you about that. I mean, I'm more than happy just to throw the ball to you and say, do you want to open up by sharing some thoughts about that based on your article, and we can go from there, or I can ask you some specific questions. How would you like to do this?
Oh, I could just speak for a couple of minutes off the top of my head, as it were.
Cool.
Sure. So, based on the article and that title, I think it could be broadened usefully to say not just bigger stormwater drains, but the whole question of urban form and urban planning.
Yeah,
we have a lot of asphalt and concrete in cities, right? And that's stuff that water can't flow through, so it flows along. And so if you've got a lot of roads and concreted surfaces, the water can't flow away, and that's when you really have problems with floods. So I think designing our cities and our communities so we've got exposed streams and we've got wetlands, we've got grassed areas, trees growing, mixed in with the built environment, that's going to help a lot. Not even thinking about the pipes, the stormwater pipes. Of course, there's all sorts of reasons why we do need to look at upgrading the stormwater system. A lot of the pipes are very, very old, and in Wellington we've had all sorts of problems the last few years. So if you're looking to put in new stormwater pipes, then you should be looking to put in bigger ones for sure, because the heavy rainfall events are only going to get heavier. And we know this from it's essentially basic physics that the amount of moisture, the amount of water vapor that air can hold is just a function of temperature. As it gets warmer, you have more moisture in the air. And this is an exponential relationship, unfortunately. So the amount of water in the air, or the amount of water vapor in the air, goes up very rapidly as you warm the climate. And when you have a way of getting that water out of the air, turning it back into liquid instead of gas, such as a storm, such as we saw on Friday, you can get a lot of water falling out of the sky very quickly. And I guess the other thing I'd say up front, I think I mentioned it in the article, it's certainly been talked about quite a bit the last few days, is the idea of atmospheric rivers. So we have these, and these have been known for a long time, and they've been called various things, but the name atmospheric river has kind of got into the public consciousness the last few years. So you hear about them quite a lot these days. And they're just streams of moisture. Most of the moisture in the atmosphere is in the tropics because that's where it's warmest. And sometimes you get these really long filaments of very moist air coming out of the tropics and heading for, California is a classic example. That's where these things were first studied. Right. But Auckland and other parts of New Zealand are equally exposed. And this is essentially what happened on Friday. So you get these big streams, you can't see them because water vapor is transparent, but the amount of water in some of these things is massive, as much as the Amazon flow. It's huge. And if you're increasing the volume of water in these atmospheric rivers, and we know that's happening, and the latest IPCC report says it's high certainty that these things are going to get worse in future. You're going to have 1.5 Amazons or 2 Amazons if you warm the climate a couple of degrees. It's not that all of that water will fall on Auckland or whatever place it's aiming at, but a good fraction of it will, and you're going to get into bigger and bigger trouble. And at some point, these sort of flooding events are going to be unmanageable. We talk about adapting to climate change, but there's a point where you just can't adapt. You need to avoid getting into that situation,
I mean, I remember an episode of QI, which is where every layman gets all their scientific information, James. And I think
Of course, yeah.
Stephen Fry asked the question, what's the world's biggest river? And of course, they all said the Nile, the Amazon, they all got it wrong. And he was talking about atmospheric rivers. He was saying there's a river,
Yeah.
river in the sky is the actual biggest
Yeah.
quote unquote river in the world right now. So, I mean, so it has been amongst, I guess, general population information for quite a long time. But when I read that in your article,
Yeah.
it made me think, what is that? Oh, that's right. I remember that episode that they were doing that.
Oh, well done. Very good.
Yeah. I also wanted to know, because you talk in your article about a 7-degree change, so 7% more 7%. Water vapor, with a 1 degree change.
Yep.
And we're already at that. I was going to ask you a question as well, because part of your article talks about it's not necessarily my layman's terms, a direct 7% change. You say, while the atmosphere now holds 7% more water vapor, this convergence of air masses means that the rain burst can be 10 to 20% heavier. So are you saying that 7% more water vapor in the air can be up to 20%? Like, I think about water vapor in the air and I think about going to a rainforest, the tropics. It's really big, fat, heavy rain. Do you mean heavier rain, heavier falls from just 7% more in the air?
Yeah. Yes to all of that. And it's gets to be quite a complicated story, but basically you've got more moisture in the air. You're 7% more with a degree of warming.
Yeah.
It's all about how what happens next. With a storm, you're bringing air together. The air rises in the middle of the storm, so it's got to come in from all over the place. So you're bringing in this moisture air from a whole lot of different regions, and you're basically concentrating it. It's a bit like, getting water in a mop and wringing it out into the bucket. But
gotcha.
You're bringing more than just 7% more moisture. And there's no real formula for this. NIWA have statistics on, depending on the duration of the event you're talking about, how much more rainfall you'd expect with a degree of warming. But basically, the shorter the burst of rainfall you're talking about, 10 minutes or an hour, you can maintain a really heavy rainfall event for a short time.
Right.
You're talking about a day or 3 days, well, you can't. You tend to get a 7% increase in the rainfall, that kind of number. But for a very short burst, say from a thunderstorm, which again brings air together, pushes it up into the atmosphere very quickly, but it might only last for half an hour or an hour or so, you can get extreme rainfalls in those situations. So for very short duration rainfall events, you can get, I'm not even sure what the statistics are, but more than 20% increase with a 1 degree warming. And it's kind of how long is a piece of string? With the right atmospheric conditions, you could get 50% more rain. And we've seen some of the statistics from Auckland and other places the last few years, the rainfall was double what the maximum that have been measured before.
I heard them say in a 24-hour period, Auckland got 3 months worth of rain. Yeah,
I think Auckland Airport got its total January rain in 3/4 of an hour.
Wow.
It was incredible. It really was. And it was a very extreme event. And even in 50 years' time, I think it would still be considered to be an extreme event. So it's not as though we're going to get these rainfalls every time there's a storm in Auckland at all. It's going to be a very occasional thing, but it's obviously something we need to prepare for because it does happen.
Speaking of preparing, you talk in your article about spongy cities, and I did a little bit of looking up on this. This is actually the link from the conversation article, and that Auckland ranks as the world's spongiest city. And so for people to know what that means, here's an example. And as you're saying, it's the green area is basically a way that the water can pass through as opposed to run down concrete. But I guess my question is, and maybe this is more for an urban planner, is how do you do that within a city where there's already infrastructure? Like, is the only way to fix this potential problem for Auckland now the stormwaters? Because you can't go ripping up half of the concrete at the moment and grassing it. So do they have to put up with that problem now and then deal with how to move it away from the city? Or could Auckland become, for want of a better word, spongier?
Yeah, great questions. And I was very intrigued to see that Auckland is rated as the spongiest city, and yet it had this huge flooding problem. So not sure how those two facts line up. But anyway, I think you're right. You can't just demolish a whole lot of buildings and, dig up all the roads and turn them into parks. That's not going to work. But you can do a bit. I've seen some examples from some cities overseas where just for example, there used to be a stream that flowed in a certain area, and it got put into a culvert so they could build a road over the top. And that stream has been re-exposed, and you've still got the road, but you've got a little grassy strip down the side that the stream runs in. And it's designed so that if there is a heavy rainfall event, that grassy strip and the streams in a bit of a mini valley kind of thing can actually hold quite a big flow without the road getting flooded. So I think even in Auckland, you could do things like that up to a point, right? You can't go everywhere and just turn everything green, but I'm sure the city planners could look at where it's possible to do that kind of thing, or where it might be possible to add, a sort of nature strip, plant some trees. All of those things can make a bit of a difference when it comes to the crunch. And I think, the pedestrianisation of parts of Queen Street or city streets around the country, around the world, that's another great opportunity. If you close off a part of a road to cars and you allow, public transport and bikes and walking and so on, you can then turn some of what was the street into a grass strip or a bit of nature, for want of a better expression. So
I was also going to say that we're obviously talking about Auckland, but this can relate to any city. I mean, we in Dunedin here had a flood in 2015 in South Dunedin that was particularly bad, and that came down to I don't want to be too overly simplify this, because there is a problem with where the land is compared to the water table and the rising sea. There's a problem in South Dunedin for that, but it seemed to primarily be the stormwaters here were being blocked up. You say in your article the country's stormwater drain system was designed for a climate we used to have 50 or more years ago. What we need is a stormwater system designed for the climate we have now, and the one we'll have in 50 years from now. It just made me think, James, if only there was like some kind of government initiative that could look at the stormwater pipes, and maybe whilst they're looking at them, maybe throw a couple of the other water pipes in, maybe 3 in total, and look at the best way to make those work for the current plan and for the future. That just might be a place to start, is what I'm saying.
Wouldn't that be great? Yeah,
I mean, it might be,
Yeah. So look, you're quite right. A bit of direction from government on all of this stuff, and having a national strategy that local authorities can follow, because it's local councils who do the digging up the roads kind of stuff. That's something that's been lacking in this country for a long time, and I hope through the whole, national adaptation planning, climate change commission work, etc., that kind of thinking will become more common, that there will be national plans for what we do with stormwater, and there'll be some funding from central government to help change things where necessary. So, it's an evolving area, I guess, but we need to get on with it.
The other thing you said in your article, that the mayhem in Auckland, the type of storm which brought the mayhem, but you said it wasn't especially remarkable. That I have a bit of trepidation with that statement. What do you mean though? Because from looking from the outside in, and I'm in the bottom of the South Island, but obviously for anyone who's seen the photos and imagery, it looks remarkable. So what do you mean it's not especially remarkable?
Yeah, and I wasn't trying to be flippant or rude there. What I was looking at were satellite pictures of the clouds and output from weather prediction models, the maps of the surface pressure and all of this kind of business. And I wasn't looking at the social media feeds and so on when I was thinking that. It's just that, a storm came out of the North Tasman Sea, and there was a front, and there was a bit of moisture coming out of the tropics. I mean, you see that often on the weather maps and in the satellite photos and all the data you can look at from the Met Service. So I thought, it's going to be wet in Auckland, but I didn't see, it's going to be super wet. There's going to be a big flood.
Right.
All of the really severe thunderstorms that kicked off were not something you'd notice from just looking at the sort of data I was looking at anyway. So broadly speaking, if you're just looking at weather maps, it was a fairly run-of-the-mill looking storm. Obviously, it wasn't, right? It had so much more moisture associated with it than you would normally get in a normal storm. So, what I said there, I feel like I should retract a bit. It clearly was not a typical storm. But what I hear you saying, and this is interesting, because the mayor of Auckland has kind of said nobody knew, but it almost seems like you're saying that's fair, because you're not saying you weren't expecting a massive flood, but you could see a storm coming. Yeah, well, that's a good question, and one to ask the Met Service, I suppose. They did have heavy rainfall warnings out for the Auckland and Northland region well in advance of the storm, and they were orange warnings, I think, which means severe but not crazy, not off the charts. And look, they've got access to a lot more data and they've got a lot more knowledge than I have. But I guess what this is saying is that they could see it was going to be wet, but not necessarily as wet as it was. Right. And it was only once these thunderstorms got going, well, they upgraded their forecasts and you could see these maps of where the thunderstorms were going and everything, and that was all handled very well. But the emergency services in Auckland would have been alerted at least a day in advance to the fact that it was going to be a heavy rainfall event over the coming 24 hours. So there was warning, but not warning of the intensity, I guess, of the really extreme intensity.
Yeah. Speaking of the Mayor of Auckland, I'm hoping we aren't like holding up a tennis game for you or something, and I'm appreciative that you are speaking to these media drongos today. So I do appreciate that.
I was hoping to get. Actually, I've got a dentist appointment this afternoon, not a tennis game. It's a bit sad, isn't it?
Yeah, I guess so. Well, you can finish up with these media drongos shortly, and then you can get off to that. Hey, I guess the last question, and it's probably a big question that's going to be, months, years, decades to figure out. But what do we do? What do we do from here?
Well, I think, like I said in the article, one thing we all have to do, all countries of the world have to cut down their emissions of greenhouse gases. We have to stop burning fossil fuels to power our lifestyles, because that's what's adding to the problem. The more of carbon dioxide and other gases we put in the air, the more it warms up, and the warmer it gets, the harder it becomes to deal with these kind of extremes. So that's one thing. But in terms of responding and getting ready for the next big flood, then we need to think about the kind of things we talked about, urban design. If you're building a new subdivision or new town for that matter, think about building in this kind of sponginess. Think about having, there's a park not far from where I live that's down deliberately below the level of the houses around it, and it's got big drains built into it. It's designed to turn into a lake when there's a heavy rainfall event to avoid having the houses around their sections turn into lakes. So, we can just be smart about how we design our suburbs, our towns, our infrastructure. So a lot of that sort of thinking is going to be useful, and we need to get on with it. There's been a lot of talk about this for decades, but I don't know there's been a lot of action in terms of redesigning cities that are already in existence, or implementing that kind of thinking for new developments. So as well as the bigger pipes, if you're digging up your roads, stick some bigger drain pipes in. And I think government's known about this for a long time, and that has been happening in some parts of the country at least. And that's one of the issues, that it's very patchwork. Some councils are onto this and others aren't. We need a bit more uniformity and a bit more direction from central government on how to proceed here. Yeah.
I wonder as well about local body politics. I mean, it seems that we've had a bit of a swing in the last elections last year, kind of away from people, let's say, with an environmental focus, more to back to people with a business focus. And so it's not till it's like I always say to people about buying insurance. Insurance is the biggest waste of money you ever spend until you need it. Then it's the best money you've ever spent. And it's a bit the same with this, typically who those people are in leadership don't matter until they really matter. And Auckland at the moment is seeing an issue where leadership and direction really matters. And my opinion, James, you don't have to speak to this. Leadership in Auckland seems to be falling a bit short at the moment. So you don't need to speak to that though. You're a professor and possibly not, but that's fine. Look, I really enjoyed you being with us, Professor of Physical Geography at Victoria University, Professor James Renwick. Thanks for joining us. It's been really insightful.
Oh, my pleasure. Great conversation, Pat. Thank you.